Hey folks, welcome back to video 2 on the Sabre final drive. As you can see, the final drive and the rear wheel are back installed. It functions flawlessly, and I'm really happy with the end result. Okay, at the end of video 1, I told you I identified the bearing because it was difficult to do that. I had to go through and do a lot of research online to actually find the name or the type of bearing this is. And we're going to go over all that. In fact, I'm calling it Bearing Nerdity. We're going to go over some bearing stuff in regards to this particular bearing, comparing it to other deep groove roller or radial ball bearings, and essentially educate you, like I educated myself, on what this bearing is, why it's used in this application, and I think you'll get a lot out of that. Now, right after that part, we're going to go back in time a little bit, you know. Do-do-do, do-do-do. I can't do that sound effect. We're going to go back to before I actually understood what that bearing was, and I'm thinking I can cheat the bearing purchasing gods.
No one can cheat the bearing gods.
You know, because the original bearing is probably 140 bucks with shipping and tax. And I don't want to spend that much because who knows what the status of the rest of the final drive is. And so I want to try to find one locally, a 6305, and then I ordered a Koyo, you know, actually name brand, 6305 standard from Partzilla that was on a Kawasaki, believe it or not, parts fish. That's the one we're going to ultimately show you on camera installing into the final drive. Push it in, and then we will torque it up, basically ugga gun it in, and then we're going to, because I blued up the pinion gear, we're going to go ahead and print that and also do a backlash inspection. Now remember, at that point where I put that Koyo substitute bearing in, so to speak, I still don't understand the importance of using the proper 6305 RBI bearing in this. We eventually get there, trust me. But at that point, I still am completely, I don't have any idea what I'm doing, basically. So at some point in time there, I come to my senses and I said, you know what, I'm gonna have to use the proper bearing because I found out what it was, I did the research and said, I can't just use a standard deep groove radial ball bearing in this application. I found one for about 100 bucks, including the tariffs and the fees and taxes out of France, actually, bearings123.com. You'll see it actually in the Bearing Nerdity section. Off camera, I'm going to get that one installed, and then we're going to also blue up that pinion again. We'll reprint it. I do show you that, and I do show you the second backlash inspection utilizing the proper bearing. So also in this video, there's going to be a couple of machining ops that I'm going to include. I think I know everything I need to know about doing this, but ultimately in the end, I realize I don't know nothing about final drives, but I know a hell of a lot more now. I hope you do too by the end of this video and get something out of it. So with that, let's go ahead and get on with the show.
And now, get ready for Bearing Nerdity.
Okay, folks, I'm going to give you the Reader's Digest version of all this material. Now, this particular handout or this particular publication is a reference guide from SKF Bearings. I know this is a Koyo, but you have to assume that the ANSI, the JIS, or DIN standards are pretty much the same. And it talks about 4-point contact ball bearings and why they're 2-in-1 bearings. That's exactly what we have here. We have a 4-point contact ball bearing, the one that came out of it with the split race. A 4-point contact ball bearing is particularly good at handling axial loads, but in 2 directions. Think about an angular bearing, one that has a high raceway for the balls just on one side of the bearing. That is only really good for it taking an axial load in that direction. Well, this one's got high raceways on both sides, as we're going to see here up close here in a moment. So it can take axial loads in both directions, and of course a certain amount of radial load as well. So let's go ahead and apply it to this pinion and ask ourselves a question. Does this pinion experience axial loads in both directions? Naturally, the answer would be yes. So let's put it in simple terms here. If this pinion was turning in the direction of that arrow, let's think of it like a boat propeller. You can see the angle of the gear right there. Which direction would it be applying axial load in? If you said this way, you'd be right. And I'm not sure which direction this rotates in when it's under power. In other words, the drive rotation as opposed to the coast rotation. Assuming I have my rotation directions correct, it would simply be the opposite axial direction. Let's talk about raceways. We need to look at the raceway construction between a standard deep groove ball bearing like this one I got from Bearings Marketing. And we'll look at that center section here in a minute. And the actual raceway, that would be the outer ring of the ball bearing, compared to a 4-point contact ball bearing. So if you look at the right one there, that's a standard deep groove ball bearing raceway. And the left one is the old 4-point contact ball bearing out of the final drive. There's substantial differences between the two of them. The degrees on the 4-point contact are supposed to be 35 degrees with a high raceway wall, as opposed to the standard deep groove ball bearing on the right, which has a round raceway. It's different on the 4-point contact, and it simply does not have as high of a sidewall or raceway wall as the 4-point bearing does. We'll go ahead and take a look at the center section now of a 4-point contact ball bearing. That's that split center raceway. And it's important in one feature alone. With a split center like this, you don't have that big carrier for the ball bearings like a standard deep groove ball bearing does. And as such, it doesn't consume so much real estate. So you can put more balls inside a 4-point contact ball bearing than you can a standard deep groove ball bearing. And it's really important to note that the inner races, these split races, have the exact same design as the outer race. In other words, it's a fairly deep or fairly high walled inner raceway. Let me show you the difference between the cages, or what I called them before, carriers for the balls on both of these types of bearings. Now, that one on the left there is the old 4-point contact ball bearing. The one on the immediate right is that Kawasaki one I got from Partzilla, which you're going to see here in the next sections of this video. We're going to try to cheat the system and substitute that one for the proper bearing. These particular carriers or cages come in two styles for a 4-point contact ball bearing. They're either that plastic or they are a machined brass type. And I have an example of both here, and I'll show you. Here's the plastic cage that came out of the original 4-point contact bearing. It's actually got an acronym of PEEK, some polyethyl ethyl keister or something. That's not terribly important. And this is an example of the machine brass style. Now, this is the brand new 6503 RBI split 4-point contact bearing, just like the one that came out, except it has that machined brass cage in the center instead of the PEEK one. This is the one we're going to be ultimately putting in. Not in the immediate future, though. Again, we're going to try to cheat the system and put that Koyo one from the Kawasaki on Partzilla that I picked up. It's in your upper right there. And then we're going to finally realize our error. Order this bearing, which came from France, bearing123.com, and we'll go ahead and put it in. But you can see that this bearing has got 9 balls in total, just like the old one. 9 balls. And one of those standard deep groove ball bearings not only has smaller balls, but they only have 8 balls per bearing. So there's 2 of the balls. The one on the left is the larger ball that comes out of a 4-point contact bearing. The one on the right comes out of that Bearings Marketing bearing that I cut open. And you can see the halves laying right there. And there is a substantial difference in the size of those 2 balls compared to each other. So here's that size difference between the bearings. You can see the one on the left is from a 4-point contact ball bearing, the old bearing. See how much bigger it is from the one on the right? The one on the right comes out of a standard deep groove ball bearing. So the next question you might ask is, can a standard deep groove ball bearing handle an axial load? The answer is, of course, yes, but it handles it differently, and it's beyond the scope of this video really to get into that much detail. Let's just say that it does not handle it anywhere near as well as a 4-point contact ball bearing, and we're going to discuss the exact reasons right now. Remember, you have that high raceway wall on both sides of the raceway. You can see the ball dangling in there and illustrates that. Both sides of a 4-point contact ball bearing raceway, both the inner and the outer, which have the same geometry, have high sidewalls or raceway walls. The standard deep groove ball bearing has that cage that consumes a lot of real estate, and the balls are less in number and they're smaller in diameter. so the axial load bearing capability is lower. So the net sum is right there in the title. The bearings are 2-in-1. What does that really mean? Well, you have an axial load bearing capability, also somewhat radial load, primarily axial load. But the 2-in-1 is in order to take a bearing, a regular deep groove ball bearing, and make it do what a 4-point contact ball bearing does, you would need two angular ball bearings, specific angle ball bearings that are essentially opposite each other or facing away from each other to handle the axial load that one 4-point contact ball bearing can do. And the reason our situation is quite obvious, take a look at the pinion here. We just don't have the real estate on the axial direction to accommodate two bearings in tandem. So we got to use a different bearing. Ergo, it's a 4-point contact ball bearing. Well, there's got to be a catch. If it's a perfect bearing for this situation, there's got to be some sort of Achilles heel, or there's got to be some sort of caveat. And there sort of is. Being that it's a split inner race, like you see in these photos here, you have to have a tremendous amount, or a really good solid amount of force that's squeezing those together, squeezing the center of this 4-point contact ball bearing together. Otherwise, you'd have a little space in there, and that would make it sloppy between the inner race and the balls. You know, kind of like this clip from video 1 when I showed you the slop in the bearing between the races and the balls. Do you see what's missing here? You see what I failed to recognize as being a critical part? So I took the liberty here of making you up a rudimentary type kind of kindergarten level drawing to give you an idea of my stupidity and to show you how this thing holds itself together. So if you look from the very right to the left, you see the coupler itself is highlighted in that green dotted line, and the nut is solid green. And you can kind of see it's over a threaded part of the end of the pinion that sticks in toward the final drive shaft itself. And that coupler shoulder, which is the backside of the coupler against the bearing center, that's what pushes against that center of the bearing, which would hold those two halves together. Then you see on the other side of the bearing, which is indicated, the bearing center indicated in red, you see that there is a 2 mm spacer in gray. And then, of course, the gear, which is kind of a half-assed version of the gear, but it's best I can do with the drawing software I have. So the gear is the shoulder on the other end of it. So this thing all gets pinched together by that nut, and the coupler is held in likewise by that nut. So there's no question that those two halves, part of that bearing, they would get squeezed together, so they would be, the two faces would be against each other. And therefore, if there's nothing pinching that together, the bearing is going to act as if it's loose or worn out. I've got a 6205 KBC bearing, which made in Korea. Now I showed him this one. He immediately looked at it and said, well, that looks like an angular, not an annular, but an angular bearing. And I said, well, if you look in online and you just Google this number, it comes up as a deep groove radial ball bearing. So I was thinking maybe this is a deep groove bearing and this would not be. And that's the difference. The difference is that it's a deep groove, and ergo, you know, this is essentially going to handle the axial load. So I'm thinking to myself, if that's the case, then we're going to have to probably order the original one, 125 bucks. But then I looked again at this online, and this shows it as a deep groove radial ball bearing of the same number. This, by the way, is a 2 mm spacer, the one that came off of there. I measured this up, and I said, well, if it's 2 mil, it's going to come up around 80 thou. And yep, it comes up at 78. So this is not a crush washer. It is ferrous. It is 78 thou. So this is a 2 mil. We will definitely use that. Let me get my mics and we'll do a little bit more inspection. According to the parts fish, there's your bearing right there, $125.16. You can see that it's the same Koyo and that 6305 RBI. Now, what does the RBI stand for? I think I mentioned before, RBI stands for a bearing manufacturer, according to this, RBI Bearing Products. There's a Kawasaki bearing with the same 6305 at Partzilla when I did a Google search on it. That bearing is $14.38, 6305 standard roller bearing. So I don't know, I don't really understand this at all. I'm completely not getting what in the hell the purpose of this bearing is for, as far as it being 3-piece, and the service manual not having any reference to that whatsoever. The only thing it references as far as any clearance or anything like that is a 2mm spacer in here, or reuse the one that came out, which we'll probably do. If I get a new 6305 bearing and the width of that bearing is exactly the same as this one, I don't see what the difference is going to be as far as this kind of offset in there, except for the fact that it won't have that axial run out. Yeah, this is really strange, because I don't know, I honestly don't know what the hell is going on with this. 667 and maybe 3/10. And this one is slightly narrower technically. It's about 667 on the nose, but it's only a couple of tenths. And the center is going to be exactly the same. Yeah, this one is actually closer to the outside of the other one, of the old one. 667 and a couple of tenths. That's a pretty good feel. 2.441, exactly the same. So the width is the same, the OD is the same. And of course these are captured on both sides. Tell you what, I'm going to clean this grease out. I use kerosene on this. I also clean the old one out too as a comparison. That way it leaves a little bit of an oil residue while we play with it here, instead of doing it completely dry. And if you wiggle the inner race, you know, you feel a little play in these, but there has to be. I mean, if there's no play in them, then, you know, there's not going to be room for any lubrication. When you put the two halves back together, and I did clean this one in kerosene as well, and give it a good squeeze. Of course, this thing is sloppier, but not a whole lot more. What it is rough. Whereas this one is nice and smooth. There's some material missing on the outer edge because there's a shoulder for the seal to sit on each side. And will that remove some of the strength from this side wall here? I don't know. Okay, here's what I decided. We are not going to use this KBC bearing. It's with the cutaways and the shoulders for the seals in here, I just don't want to trust it. It's not close enough to what, I mean the dimensions are, but close enough to what this original was. I'm going to get this Kawasaki one, which is in stock. It is a 6305. It is a Koyo, same brand, and it does not have any of the reliefs in it for seals. It's a regular open, deep groove radial ball bearing. And that's the one I'm going to order here in about 2 seconds, maybe 3. And what else is wrong with this final drive? I don't know. I can't justify putting 125 bucks into it. Just in the amount I ride it, I mean, this is going to be perfectly fine with just a new bearing. So we're going to order that Kawasaki one and wait a couple days and get it. I'll throw it back together on camera, you know, a little bit here and a little bit there. Yeah, I think that is a safer play than to use this one. And that came today. So let's open it up and take a look at it. Kawasaki. How do you get this open? Jesus. It's a Koyo, like this one. It's the same number, 6305. Let's measure it up like we did this one. 65, 667, maybe 4/10. That's about 1,000th thinner. And this one is 441. Same exact OD. Definitely seems tighter than this one. In this KBC. Okay, so let's take a look at the housing and all that crap. Ta-da! Check out this abomination. I made this morning. First thing that jumps out though is, yesterday I painted this, which was not the easiest thing to do because it was soaked with freaking gear oil all over it. Came out pretty damn good, to be honest with you. How I made this was pretty simple. I took this piece of 2x10, I guess it is. The inside here, I don't know what it's called. The thing that goes into the spline that drives the rear wheel and goes into those dampers on the rear wheel itself. I guess it's like a spider. So I took that and I laid it out on top of this 2x10 and just traced the spot where those pins sit on the piece of board. And so this process dead tree carcass took a regular drill, I think it was a 1/2-inch drill bit, and drilled those out, which of course they didn't line up, so I got smart and put it in the drill press and put a 5/8 drill through those holes so I could actually get these pins in. I'll show you that again. So those things sit inside of it. You can see I got a piece of all thread through it. I drilled that hole too, and this is 7/16 all thread. This is the only nut I had for it, which is just one of these connector thingies. Now this washer is a special washer because I found this washer on the side of the road this morning taking the dog for a walk. I dropped it in my pocket and I said, I can use that for something. I did not want to have the all thread pull this down so it's squeezing between that spline spider dealio and the processed dead tree carcass. So I blocked it up so it's right on a couple of bolts that go into the back cover. And this is actually a little bit loose, which is what I want. I want this spider thing not to be, you know, super tight. You can see you can move it a little bit. So take my word for it, you can move it so it's not bound and pinched in there. Now the whole purpose of this thing is to give it a purchase so I can actually torque that thing up, handle it better, because I put this thing directly in the vise, I'm going to screw up this nice paint job. So all I got to do now is take this dirty rag out of here. I always use dirty chip-laden rags on any high precision piece of bevel gear. And you can see down inside there, that's what she looks like still. Now that bearing down inside there, I did check that by taking the actual pinion itself without any, bearing on it. Shoving it in, it does engage with the bevel gear, but you can kind of wiggle it and feel that the bearing in the tip there, it would be like a pilot bearing. That is nice and snug. It's nice and tight. It's not loose, so that's not the problem. It's most definitely it was most definitely the main bearing, that 6305. Go over to the press first, and we're going to press on that 6305 on the pinion with that 2mm spacer that they say to use in the service manual, and it is 2 mil. We're just going to reuse that. And then we'll come back here and get it installed. Now, I'll tell you right now, according to the service manual says to blue that pinion up, that gear, with like Prussian blue, which I do have. Take the fill cap out right here, and you can look through the fill cap as you turn it around and then see what the printing is between the pinion and the ring gear, and determine to make sure that your meshing is appropriate. I don't know if we're going to be able to do that because it still has some oil. We'll take this out, and if it drains some oil out, we'll just let it drain. In fact, I'll do that right now off camera, and let's go over and press that bearing into the pinion. I got a pusher, which is an old fork tube, which fits perfectly over that, which will go right into the center and push the bearing from the center where you should push this bearing. And I have the push the bearing. I have the spacer. Okay, that's promising. Started to go even without the rod. The pusher rod. Let me bring my big rod to bear here, and then we'll see what happens when we push it in the bush. What I need is an arbor press for this kind of stuff. I don't have the room for it. I'd love to have one though. All right, she's definitely down on that spacer. Oh, that is so much nicer than that original one. Let me tell you what. Okay, now let's go back over to the actual final drive body. We got to figure out a way to bang this in. Time to make the donuts. Whoops! I hate this f***ing saw. Somebody's gonna have to teach me someday how to keep blades on that stupid Harbor Freight saw. No matter what I do, no matter what blade I use, no matter how tight I make the damn thing, it throws blades constantly. Okay, so that's what I just made. It's a pusher to bang this thing in. It's open in the top, but it won't be for long because I'm going to put one of these bearing drivers in the top of it and hit it hard with a hammer and then get this thing started. All I have to do is get down below the threads, 3 or 4 threads or so, with the bearing and the whole pinion and everything. And then we can use the, what do you call it, the carrier? Yeah, the retainer, and put it in there. I taped up the sides of this so we don't bang the threads up. This is going to be a little risky. It's pretty close to the threads, diameter-wise. So if I'm hitting this, because it's going to start probably, oh, I don't know, right about the top edge of those threads based on the thickness of the bearing, the width of the bearing and the threads. You see the width of the threads are probably about the width of that bearing. So when it hits that bore, we're going to be right at that dangerous spot. And if we screw up those threads, then it's all over. There ain't no way to correct that. Now I've already put the retainer in and made sure the threads are okay, because I did clean all this up with some wet or dry earlier. Made sure I didn't nick them or anything. It goes right in, no problem. And we're all cleaned up, ready to go. But this fits perfectly, just slightly smaller than the bearing diameter. This is the old bearing, of course, and I think it is going to be just fine. I bored it out just to get the flaky zinc out of there so it doesn't shed inside there as I'm beating on it, and same with the outside with some sandpaper. I think it'll work. Hopefully it will. Let's give it a shot. Now I drained out all the rest of the oil. I put some Prussian blue on the pinion. Well, if we screw it up, at least we have a puller that we know works. So the other thing is oh, there it goes. I was going to say it's got to start in that front bearing first, because if it doesn't, then how do you know you're not beating on it and you're hitting that bearing on the edge of those rollers? But now it's in. It's definitely in that bearing. You know what? I'm already seeing threads. Look at this. So we are a little bit down in there. Yeah, well, being that I've never done this before, I'm just guessing. Oh yeah, I see threads. I see dead bearings. Shit, this is going down, no problem. I'm just going to drive it down the rest of the way with this. Yeah, see? That's perfect, right there. That's like perfect backlash. You can't get any better backlash on a pinion gear with a ring gear right there. Doy. I think it's down all the way. That is a lot of play in there. Should be in further than it was, so maybe it just needs to get torqued up to go the rest of the way. I don't even know what the backlash is supposed to be. I gotta go look it up. We could check that. I put that O-ring down behind the spline there. Got that in. That's the one that lines up to the inside of that coupler. There's the O-ring. The O-ring is starting to seat now. On this nut, where it lines up to the retainer up in here, I put a dot on the tooth that lines up to that. In other words, the retainer, which looks like a little dog bone thing with a cutout, goes on either side, or went on either side of the tooth with the dot. So when this thing is tightened up, if that dot is like way over here, then we got ourselves a problem. But if it's really close, or dead nuts on hopefully, then I think we might be shitting in high cotton. Well, the backlash is supposed to be 3 to 7 thousandths, but measured on the ring gear, so you got to put an indicator in here. Ugh, I don't know if I can do this without the whole thing turning. As the final drive turns. Yep. I don't think we're going to be able to do it this way. No way. Well, let's do that. Man. This is the right tool. It doesn't really bind in those teeth very well. No, it doesn't. Nope. Can't get it up to 80. There's no question about that. I did it once, but... Well, we're going to do it the old-fashioned way. Sounds like 80 to me. This thing puts out some damn torque. And it did, well, stay. And it did turn a little bit, so I think it's torqued up just fine. Okay, I'm back on the jig here with the blocks back basically where they were, but I don't have the spider locking this thing up in the center, so this thing's free to turn. I'll show you you can definitely see the pattern of the Prussian blue on the ring gear. I'll show you that here in a minute, but what I want to do is I want to check this backlash. It's supposed to be 3 to 7 thousandths at the ring gear with the pinion locked up. I had the pinion locked up with that special tool that we put in here to pull it with, and we made the shaft to go into this M28 and a pair of vice grips, and it's just bolted right down with a big old washer, and this thing can't turn up here, so they want you to move it down here. So I've got to find an indicator I can stick in there and get on one of the teeth, and then reach in there gently with a screwdriver and move it back and forth, and we'll see what the actual lash is. I can reach around the backside and move the ring gear from that spline. So I've got this Rube Goldberg set up as far as the Mitsutoya, the Brown and Sharp indicator rather goes here. So that's really not that bad. We're right at the limit, about 7 thou. Indicator's probably moving a little bit because it's not the best setup, but yep, 3 to 7 thou. That's the standard. We're right at about 7. And guess what the service limit is? 20. Concerned about that I'm not exactly square, if you will, on that tooth in there, but it's the best I can get. This is how I'm locking it down. With that pair of vice grips on that tool, and then a 1, 2, 3 block that's bolted through a pair of vice grips that's holding the whole damn thing together with that thing bolted to one of the studs. Hey, you know what? Any port in a storm if it works. It's kind of messed up now because I've been turning it around, but see if I can get a little bit more light in there. It's smudgy, you know, but it's kind of high on the gear as far as toward the outside. Really, I think that ring gear needs to be shimmed inwards a little bit. And it's got a slight angle to it. I don't, it's hard to tell because it's so smudged out, but I'm not sure. So you can change those shims, but I don't think it's that far off. And besides, because this bearing was so wore out, and the way that pinion looked all polished and the way it was worn, I can't really rely on this because I think the pinion is worn irregularly. Now, is that going to make a hill beans a difference for us? Probably not. Because it ain't going to slip. We got good backlash. And, you know, just because we have a little bit of irregular pattern here. But it's still not bad. You know, it's not terrible. Can't really see the other side too well. Yeah, and you got a better view of it than I do now. Let's both look at it through the camera. So there's the other side. I don't know which one is the trailing and which one is the leading side. So which one is power and which one is coast. You know, it's not terrible. It's pretty even. And with the wear that's on that pinion, I just don't think that it's worth, whoops, I'm hitting your head, sorry. I just don't think it's worth doing a whole lot about. We've solved the problem. In fact, let me show you that. We did the same kind of shot when it was on its side when I was clamping it directly in the vise. I'll see if I can do a split screen, like side by side, then and now. So this is obviously now. I mean, I can feel a tiny bit of play, but hell, there's got to be some play in there. It can't be tight. Remember before, this thing was just rocking back and forth. It had a shitload of play in that bearing. And now we don't. So yeah, I'm pretty convinced that this is going to be fine the way it is, and we're just going to leave it because I'm not taking it apart anymore. This final drive is not worth that kind of time and effort. I just get another one off eBay and rebuild that one if necessary. So I'm done for the day. I don't have any time left, so we'll pick this up another day and finish this video out, just part 2. You know, I think it's going to be a hell of a lot better than what we had. Something oddly familiar about this. I wonder what that might be. Mm-hmm. Let's look at this one. Let me back you out just a little bit, which just came a little while ago. 6305 RBI. It's a little different, as you can see, but it's pretty much the same. Now that piece of plastic in the middle is just to keep these two halves together for like shipping and transport. So let's go ahead and pop that piece of plastic out. And I want to keep these inner races the same as far as their location goes. I don't want to change that. So we're going to say that this one goes opposite the side with the writing, and this one goes in the side that has the writing. So I'll keep it that way. Okay, let's count the number of balls in here. We'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this bearing, as you can see, has the other type that they talk about, which is a machined window type brass cage. And so you can see that's clearly what this is. And we could pop this right out and take these bearings out if we wanted to, just like we did with the plastic one here. But let's not just say we did. Let me put this one back together now in the orientation that it came. We are going to put this bearing on, and we are going to put that bearing on with a new spacer that I made just a slight amount thicker than the old one. And you'll see from those clips of the gear lash and so forth why I chose to do that. Okay, we're going to make some changes to the pinion spacer. This is the original one, supposed to be a 2.0 millimeter. Let's measure it up and double check that. But we're going to make one that's slightly thicker. I'll explain why here in a second when we go to before we put the correct bearing on, since we've been trying to cheat the system here with the improper bearing, and we've already identified the reason why it has to be a proper bearing. Let's come up with a little modification to maybe bring the clearances in a little bit more and bring the pattern a little bit closer to the center on the two gears, because I'm not entirely happy with the pattern. So anyway, let's take a look at the service manual. This is what I'm talking about. Here's your pinion spacer. And you can see standard is a 2.0, which is 79,000 inches imperial. This is the pattern that you take a look at, excuse me, from the Prussian blue. That's too low, where it's too much toward the inside, and this is toward the outside. Ours is more toward the outside in that pattern. All right, and that kind of goes along with the fact that our Backlash was on 7 to 8 thousandths. And that's with a bearing, with this bearing, which is that coil one from Partzilla, same bearing number. There was only about 1/1000th narrower on this width here. Essentially you would think that because everything else is constant, this would actually go into the bore a little bit more by 1/1000th, because it is 1/1000th narrower than the original one, which is right here. And so that would actually take up that space a little bit. And we still had about 7, almost 8 thousandths of backlash. Let's say 7, right at the maximum. Now, of course, the service limit's 20, but I'd like to try to dial it in a little bit closer and again bring that pattern up more toward the center. Because again, we're looking like we're a little too high. So we'll take a look at this spacer deal again. 2.0 at 79 thousandths. I'm going to go to the 2.06 or 81. And that's 2 thousandths bigger. Reason why is, it says right here, when you replace the spacer with a thinner one, and they're talking only about thinner one, but this would apply, I'm certain, for the thicker ones as well. The patterns will shift about 1.5 to 2 mil, or about 60 to 80 thousandths. Wow. And then we'll be ready to put the correct bearing on the pinion. And I tell you what, that's what happens when you try to cheat the system. You gotta get the right stuff in the end anyway, but hey, you know what? It's a learning experience. Here's the material we're gonna use, a piece of fork tubing. I can't think of a better material for this. This is not a hardened spacer. I'm gonna back off a little bit so I can chamfer that with a file. So far so good, a little chatter, but that's okay. This stuff's pretty hard. Said the wife. No drama there. I might just start parting this way all the time. Been meaning to try that. Oh wow, turn the damn part blue. Just kidding. Fooled ya. That's why it's blue. Well, the first one is 83 thou, not 81, and I'll tell you exactly why that is in just a second. Let me reface this. We're going to do it again, and I'll show you what the problem was. It is very, very, very difficult to get an accurate touch-off on a tool like this that is very narrow and can be easily distorted or easily deflected. And that's what happened. When I touched it off, I was probably touched off a thou and a half more than I actually thought, which brought us to thou and a half thicker than what we want. So I'm going to show you a method that I learned from Stefan Gingelbanger, whatever his last name is. I can't pronounce his name, on YouTube. And it is going to be bang on, just touching the surface, and we don't even turn the workpiece to do it. So let me get set up. Okay, so what I have is my tense indicator, my Brown & Sharp tense indicator, the one we used over there in that final drive, to check the lash in the last iteration of this absolute abomination of an attempted repair. Oof, glad that's over. And so I have this touched off on the outside of the parting tool, obviously. You can see it is touched off, just touching it. And just a tiny bit of preload on it. Just a tiny bit. Maybe we'll do less than that. Yeah, we just need a little bit, because this too can influence that tool a little bit. It's unlikely that it's going to do it much, but just a little touching, you know, you can only touch a little bit. And then the rest, if you touch any more, it's illegal. So what we're going to do is we're going to go ahead and bring this tool and the indicator, because the indicator is on the cross slide, obviously, until we just come up, and you're going to see it when we touch. There we go. See how it deflects? I'm going to go a little bit further here. See how it deflects the indicator when you touch the workpiece? Right there. See it just start to move. Now you are just touched. Now we're going to hit the Z. Now we are truly touched off on this correctly. Not too shabby. Now I got to go find it. Yeah, we are a little larger here, so that's all we're just going to go with this, but 80 and a half or so is fine. We went from 79 or almost 78 and a half, depending on where you measure it. Let's measure this old one again with this micrometer instead. 78 and a half. And this one is no different as far as little varying. 79. So yeah, we're about a thou and a half bigger on this one. Finish deburring this a little bit, clean it up a little bit more. Well, I'll show you the lapping thing. I don't know if some viewers out there may not be familiar with it, but it's pretty simple. It's just a fairly high precision, used to be at least, ground block that dates back to probably the 70s. And with a piece of 400 grit on it, and then you just hold the paper and just use some WD to lubricate it and just go back and forth until you get to the desired thickness. It's accurate enough. This is something that came out of the company my dad worked for like 30,000 years. Because they built production machines, so they essentially were a ginormous machine shop building machines that could either build parts or other machines. And he'd bring home things like this that were either so scrap cuts or off cuts or whatever. And I have most of these. I think my brother's got a couple of them maybe for using for similar purposes, but I've got a few of these of similar size, and they come in handy for this kind of thing. All right, guys, it's a number of hours later. I had some other stuff to do, and I went ahead and assembled that new bearing on the pinion in the press. I didn't film any of it because you already saw me push bearings on before. It is slightly different because we had to do the two halves of the inner race. Other than that, very straightforward, and it went without any drama whatsoever. And then I ended up looking at the location of that dot. I can't see it now really. Well, maybe you could. Let me show you. The dot location came out perfect. I should have shot this before I put the collar in, but I think you can see it. There's the dot right there. And that's basically where it was when I took off the original one. So that dot is in a perfect position. It's about where it was on that coil bearing too. So it kind of just goes to show you that our measuring was accurate. But here's the thing. Before I put this collar on, I grabbed the end of that pinion, moved it around, and that son of a bitch was loose as shit, just like the original one was. And I said, what the hell?
What the hell?
In other words, you could move it back and forth. It had thrust. I'm like, I can't believe this. And then the light bulb went on. And I said, you dumbass. Now, I think you remember earlier in the video, I put that kind of kindergarten level drawing up, showing you how on the pinion, how the nut for this coupler actually pulls that bearing together because it is a split center race bearing. In order to check any of this stuff, you have got to have the collar on. The service manual does not say that. The service manual jumps right from putting the bearing retainer in to checking the backlash. But in the photos, you can see somebody grabbing this coupler rather, right here. And I said, why didn't I see that before? There's only one photo actually. I just missed it. So once I put this coupler on, you know, the O-ring's down in there already, and then tightened it up, I just gave it a little ugga-dug with the impact again. There is no torque spec that I can find in the service manual on this nut. I will take it back out and put some Loctite on it, but right now it's just, you know, cinched down pretty tight. Pretty tight. Now it's nice and tight. That's exactly what happened. The inner race spread a little bit. This nut and this collar, being the way the collar hits on the outer inner race, if you will, pulled it all together, made nice and tight. I looked at everything on this original bearing with this coupler removed. So when you remove the coupler, it releases that preload, if you will, you want to call it that, on those inner races, ergo, you get slop. There may not have been any damn problem with that original bearing whatsoever. This is typical of my projects, I swear to God. I think the extra thickness in that spacer by 2 thou is helping out. The pattern between the two gears looks great. I did blue the crap out of that pinion before I put it in, made sure there was no excess oil in here, and then of course took the spider out and spun this thing around after I got, you know, this coupler on and everything right. And the pattern looks great. I will show you that again here in just a sec. Let's do the backlash instead because I think that's a little more important. Okay, you can see right now we're set up to do the lash inspection with the indicator again. You saw that earlier in the video when I did it with that other coil bearing. The reason why it looks differently is because I have the coupler installed. All right, let's move on. I'm going to show you the lash on this one. Remember, I did the spacer just a wee bit wider than the original one by 2 thou, I think it was. So it's the next step up on the guide or the list in the service manual. And we'll also look at the printing inside there. I'm really pleased with that. That came out pretty good. But let me show you this. As far as this goes, I'm testing the backlash exactly the way the service manual says to do it, by rotating the ring gear with an indicator on one of the teeth. And we are within tolerance. We're at the high side of the tolerance, but as I think I mentioned before earlier in the video when I did that coil bearing, the throwaway tolerance as far as the maximum tolerance is 20 thou. So I'm not really too worried about this at all. And I think the reason why even bringing it in a little closer by putting a slightly thicker spacer in is not making more of an impact on the lash is the fact that the gear is worn. I say maybe that bearing was still good, but I have my doubts that it was 100% good. I think that it was on the way out or starting to wear. There is evidence on the balls that it has some pitting, so I would say maybe I'm about 90% of a doofus instead of 100, but still doofus nonetheless. Could you even see that with the Galeria? I think you could. So there you go. Somebody's an idiot around here. It ain't you, and it is 100%. It definitely is me. Well, I got the light on. We'll leave the light on for you, but I'm going to turn this one on too. Hopefully it doesn't flicker. It's kind of hard to see this because the oil that's left in there is washing that off, but I believe if I can get more of a square shot on this thing, yeah, see we can see the top of a tooth and the end of a tooth there. I believe that that printing is a lot better. It's more toward the center of the gear, and it's more inwards, deeper into the gear too, slightly. I'd have to compare the other clip side by side to this one. Maybe we'll do that, maybe we won't. I would say that's better. And since our valve lash, Jesus, I'm working on too many motors. Since our gear lash is within spec and this looks good, this is where it's staying. Hi, I'm Mr. Gear. I'm in good shape. Shut up. All right, well, this punishment is finally over. This adventure, all back together. Now, I do have a surprise for you, though. You noticed that I did paint the final drive. While this thing was off for its extended absence, I went ahead and I did the rim. And let me tell you what, the light is kind of shitty. Let me go the other way. Yep, that is all painted and done. I cleaned it up, and I don't remember, I did not, I know that. I didn't take a before video clip, but I can pull one out of an earlier video, like when I did the tire. And that's how it looked. But I'll also go up to the front here, show you this one. This is how bad the front is. And the rear was worse, especially one side. Now, it's not perfect, not pristine. I think it's to the level it would be if the bike had been taken care of, you know, over the years. In other words, a little bit dull on the aluminum, but not spotless shiny. And it's the best I could do anyway. Now, if you ask how I painted all that, did I mask all that shit off and spray it? The answer is no. Every bit of this rear wheel was hand painted with PJ1 gloss and small brushes, the ones I get from the grocery store to do touch-up work. The brake rotor, however, was sprayed. I masked it off and sprayed it and then detailed it. I initially really didn't want to do blue, but it's all the color I had. I didn't have any silver, and I figured the blue would kind of match the blue trim on the bike, which, yeah, I don't know. It's good blue. It's the same blue that's on my Kurt Weiss. I've used it on other things on this bike too. I think it's just a Krylon, but it's a primer and paint composite mixture, you know? This section inside there that kind of looks like a turbine, that was a pain in the ass. That section right there, that was very, very difficult to clean, somewhat polish, and then paint. But I did it, and I probably got about 12 hours of work into that rear wheel doing that. But since we were tied up with the shenanigans and the stupidity of the final drive bearing, now that I know that I am stupid, well, I figured I'd use my time wisely while I was waiting for a replacement bearing to come in. Ergo, there you go. All right, so this is it on this video, or the second of the two videos. So it concludes the whole thing. I'll tell you what, I am an idiot, but I learned an awful lot. And that's why I included all that. I could have omitted all that and said, the bearing was bad and I'm a hero, but I'm really a zero and I'm not going to lie to you about that. That bearing was probably okay, or maybe it was moderately not okay. Certainly usable. I misread the whole thing. I thought I knew more about this stuff than I actually do, or did. I know a lot more about it now. I also learned that that Honda service manual, while it is pretty comprehensive, is missing a lot of shit when it comes to this higher precision stuff like final drives and bevel gears and things like that. Now, speaking of bevel gear, there is a section in there where you're supposed to rotate that around and check the gear lash in a couple different locations. The maximum allowable difference is 4 thousandths. And of course, I did that. Yeah, I didn't do it, but it's close enough. Let me tell you what, I'm not going to do that, and I wasn't going to do it because I'm pretty tired of this. And that gear is pretty worn in there, that pinion gear, so I'm just not going to worry about it. Got it filled up with oil. It's ready to go for its next run. I'll report back in the future whether or not we had a massive failure or something, but I don't think so. I think it's going to be fine because A, it's the correct bearing, and B, there is no B. It's the right bearing. It's brand new, so I put it in correctly. Got it torqued up to what I think is the best specs. There is no torque spec on that coupler. I just ugga-dugga it with some Loctite blue on it and called it a day, but I ugga-dugga it really good. So I probably put about 80 to 100 on it. Good enough. So I hope you got something out of this one and learned something. Again, I sure as hell did. I had a good time doing this overall, making stuff for it, machining stuff for it, and hey, you know, that's what the game is all about. So if you want to see more gaming, just stick around, and I'll make a fool of myself on future videos. To do that, you know what you need to do, so I won't get into that. So as usual, thanks for watching. Don't just repair, restore. We'll catch you on the next video.